Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. As you surely noticed, we have updated our music to mark over 4 years and more than 100 episodes of Energy Talks. We hope that you like our new sound as you continue to listen to our podcast series. Thank you for listening. In this episode of Energy Talks, I speak with instrument transformer testing experts Felix Feustel and Thomas Bischof about how the accuracy of power quality measurements is becoming more important in evolving modern power grids to ensure a reliable power supply. Specifically, Felix and Thomas described the role of instrument transformers in ensuring accurate wideband measurements for determining power quality and how they developed and field-tested an innovative measurement solution for it called Ferneo 800 ITPQlizer. They also talk about the importance of adhering to international standards in developing such a solution and the positive feedback they have received from the users who requested it. Felix and Thomas have joined me before in past episodes about instrument transformer testing, and I am pleased to have them back for this episode. Hello, Felix and Thomas. Thank you for joining me again for this discussion about ensuring the accuracy of wideband measurements on instrument transformers for power quality testing applications.
Thanks. Good to be here. Thank you.
Let me start with you, Felix. Could you please describe what is meant by power quality?
Yes, so basically power quality refers to the characteristics of the electrical power supplied to end users, and in particular how closely the voltage and current waveforms adhere to the ideal sinusoidal shapes. So it encompasses parameters like voltage sags, swells, very importantly the harmonics and transients, and frequency deviations. And a good power quality ensures the safe, reliable, and efficient operation of the electrical system and devices.
Thomas, what is the significance of power quality in the power grid?
Power quality is essential in the power grids because poor quality can lead to malfunctions of equipment and as well to increased energy losses. And this means that the lifetime of assets will be reduced. As well, you can have production downtimes and even damages to sensitive electronic devices. And as grids becomes more dynamic with renewable energy, and by the way this is growing in the future, maintaining the power quality will ensure a stability and more efficiency across the entire energy infrastructure.
Felix, why is the accuracy of power quality measurements becoming increasingly important?
Because now we are transitioning to smarter grids and we have more generation sources like solar and wind, and they create more disturbances such as harmonics and transients. They are becoming more prevalent. And accurate power quality measurements are more vital than ever to detect and analyze and mitigate those issues, to maintain grid stability and to ensure compliance with standards and protection equipment.
Felix, how is power quality testing different from electrical testing in the power system?
It is about quantifying the nature of the signal in the grid in a particular time period in order to quantify whether there's disturbances or whether it is a very smooth signal. So we are talking mostly about measuring or detecting the presence of harmonic frequencies. Harmonic frequencies are usually undesired, and that's what we want to measure in a power quality measurement. But it's also important, you will see as we proceed in this discussion, that what we are most interested in is how instrument transformers are suitable in measuring the harmonics in the grid.
Thomas, how do instrument transformers play a vital role in the power quality measurement chain?
Instrument transformers, such as current transformers or voltage transformers, they are responsible to transform the high voltage or currents to a measurable quantity. and they are the first link in the measurement chain, and thus the accuracy directly affects the connected downstream measurement devices. So if the instrument transformer distort the signal, especially at higher frequencies other than the rated frequency, it will compromise the accuracy of power quality monitoring.
Interesting. So, Felix, why are instrument transformer wideband accuracy measurements important in power quality applications?
Traditionally, the ratings of instrument transformers have focused on the fundamental frequency, but many of the power quality disturbances occur at higher frequencies, so like the harmonics and the transients. And this is why it's now becoming important to measure the accuracy of an instrument transformer in the entire frequency range. And for this, we are doing wideband accuracy measurements to evaluate how well the instrument transformer can reproduce the signal over a broad frequency range. And this would be the prerequisite so that we can measure the harmonics via a certain instrument transformer.
Thomas, how and when are these measurements typically performed?
Wideband accuracy measurements are typically performed in laboratories or as well in specialized test facilities, and usually they are conducted during the design phase of an instrument transformer, can be the routine test or type testing, but increasingly, because of the demand, more and more are done in field verification scenarios.
Okay, thank you. Felix, how did it become evident that wideband accuracy measurements are essential in power quality testing applications?
It was really that more customers approached us because they know us very well from testing instrument transformers as the base frequency. And they asked us, hey, don't you have a measurement method to measure the wideband behavior? OMICRON had been involved in researching instrument transformer wideband behavior and also suitable test methods. And then we observed that more customers were approaching us about such a solution. So we started to look for suitable measurement platforms, and then we decided to develop a solution.
Thomas, according to what Felix says, what type of measurement solution is required for this type of testing?
Yeah, for this type of testing, it is required that you have a high precision test system, which is on the one hand capable to inject a wide range of frequencies, and on the other hand, analyzing the output signals with a minimal uncertainty. And this measurement setup includes high frequency test voltage source, an impedance converter, and as well you need a software that you can evaluate the wideband ratio and phase error under various conditions, and which are in accordance with the international standards like the IEC or the IEEE standards.
Felix, you had mentioned before that customers were approaching you because OMICRON has been involved in instrument transformer testing. How has OMICRON been involved in testing instrument transformers?
Well, since many years, we have provided different test methodologies that are aiming at the instrument transformers. Of course, we have some test instruments to do ratio tests with primary injection, primary current injection, also high voltage injection for the voltage transformers. And all of this is traditionally focused on measuring at the base frequency. Then OMICRON is also very well known for model-based accuracy testing of instrument transformers. There we have the famous CT analyzer, for instance. And now with also providing a solution for wideband ratio testing, we have an even more complete package to test accuracy. Apart from that, but maybe this goes too far, we also have solutions to perform different diagnostic tests on the insulation, for instance, tangent delta, but maybe that's the story for another interview.
Thank you, Felix. Thomas, could you please describe OMICRON's solution for measuring instrument transformer wideband accuracy in power quality applications?
Our solution is the Froneo 800 IT equalizer. It is a system specifically developed for this purpose, for power quality measurements on instrument transformers, and it combines wideband frequency response analysis and as well the power quality specific parameter evaluations. So the system measures the ratio error as well the phase errors over the frequency and can, with that, make a clear picture about the instrument transformer, how it would behave in a realistic grid conditions.
Felix, do you have any tips for incorporating wideband accuracy measurements when testing the performance of instrument transformers?
Yeah, one tip is certainly that you should select or define the test frequency range that you want to test the instrument transformer for. There's different ranges that are used for power quality measurements, and some are more typical than others. Our solution can test up to 500 kilohertz. This is the highest wideband range that is defined in the standard. But nowadays, more typical would be much smaller ranges, which would be the range up to 3 kilohertz. That's wideband class 1, or the range up to 20 kilohertz. That's wideband class 2. So first, when you start with a measurement, you need to define in which range you want to verify the transformer. Then another very important point that we found in the development was that you need to consider the load of the instrument transformer and that you need to apply a correct load when you are measuring the wideband ratio. And for this, we have developed an accessory, which is an electronic impedance converter. And there you can select the appropriate or the fitting burden to put the correct load on the instrument transformer. And finally, when you evaluate the results, you can verify the performance against the wideband class limits that are now described in the recently released IEC standard. That's the second edition of the IEC 61869.
And what does that standard apply to?
This is, in general, the standard family for all instrument transformer types. That's the IEC standard for instrument transformers. And there's different parts for different instrument transformer technologies. So -1 is a general part. In the second edition, there's now also a description of wideband classes. So specified ranges, that's the wideband class 1 and 2 that I mentioned, for instance. And then also the corresponding limits in which errors in the wideband range for the ratio and phase error acceptable.
How long has this solution been available?
Oh, we've released it this year in January.
Have you had any response to the solution yet from customers?
Yes, already in the development phase, there were a lot of customers that were really interested in this, and we performed a lot of field tests in the last years. When we developed this, there's certainly a good interest.
Very good. And you are also to verify that it works well in the field.
That's true. Yes, we've been doing this in the last years.
Where can our listeners get more information about OMICRON's Fresnel 800 ITP Equalizer solution for measuring the wideband accuracy of instrument transformers?
Yeah, they can visit our website and search for Fresnel 800 ITP Equalizer, and there they will find a detailed product description. Also, they will find some papers or application notes, and they can also contact or request personalized support. In the area of instrument transformers, we offer webinars as well, training sessions, if you would like to have more deepened expertise in power quality measurement and for instrument transformer testing.
You can also check out OMICRON's YouTube channel. There's 2 videos available that show the application of this instrument transformer wideband ratio measurement product.
Thank you, Felix, and also Thomas, for joining me to talk about the importance of measuring the wideband bandwidth accuracy of instrument transformers for power quality testing applications with OMICRON's Fresnel 800 ITP Equalizer solution.
Thanks for the invitation, Scott. It was a pleasure.
Bye-bye.
Thank you again. And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.